All right, welcome to our online lecture on aviation safety. Today we're going to be going through a lecture on aviation safety, and then we'll have some assignments that we're going to do that are related with aviation safety as well. I'm going to share my screen here, and we're going to take a look at a lecture that we have and that you will have in your Google Classroom as well. So if you want to pull this up and follow along with, there's going to be some questions that I'm going to show you that we can answer as we're going through this as well. Before we get into the formal part of the lecture, I want to share a story with you about something that happened to me. Anybody who's been in aviation for any length of time will tell you that some kind of safety issue has come up at one point or another. My safety issue came about when when I was working down in Charleston on the Boeing 787, the final assembly building. We were swinging the landing gear, and I'm going to show you a video of that in a second. But what I want you to do is for our warm-up is I want you to think really carefully. I'm going to show you just a quick 1-minute video of what's called a gear swing, and that is where we jack the aircraft up in the air and then swing the landing gear and tuck it up in like it's flying. And we do that to make sure that the aircraft is functioning correctly and that everything's rigged properly, and that when it goes to fly for the first time that there's no issues with it. So I'm going to show you that gear swing, and as it's going on, I want you to think about what could have happened, because the outcome is that I just about killed 2 people and then I caused over $1 million worth of damage. So in just this short 1-minute video, I want you to think about what could have happened. Okay, so we're going to switch over to that. And I'm going to play this. And again, just kind of try to think. So this is the gear swinging up into the airplane. And you'll see the doors closed behind it, so it's streamlined while it can fly. You can see those big yellow jacks are what's keeping it in the air right now. And that's how it would fly, just like that. So this would be it coming down to land. Right there, the gear swings back down and the doors close. So what we're going to do is I'm just going to pause it at about that spot. Right about here is good, looking at this. Okay, so this is it swinging back down. I want you to try to think for a moment. You can pause the video, and I want you to kind of jot down maybe a couple of guesses of what you think your beloved teacher, Mr. Jansen, could have done to just about kill 2 people in that process and then cause over $1 million worth of damage. So pause it now and just kind of jot that down, just on some scrap paper. I'm not going to collect this or look for it. I'm just curious what your thoughts were. And you can share it when we meet back up. Okay, that should be enough time for you to pause it, write down your guesses. So what happened was, as we're swinging this gear, this will tuck up into the hole as you saw, and then it closes up. Well, we can do this in a way where this door stays open and people can climb up inside of here and make the adjustments to all these little bolt holes that you see. So there's somebody up inside of this, laying up in there, making adjustments to make sure everything fits right. Well, when that's going on, nobody touches anything, and we should wait until they come out. Well, I was doing a different task, and in the back of the airplane, I flipped a switch, and it was the emergency switch, and it caused the landing gear to fall down out of the hole. So as you saw this landing gear swing back down, as it was coming back down towards the ground, there was an individual standing underneath there and a big lift. Okay, so there's one person up in here, and then there's one person in the bottom, and now this 10,000 pound worth of landing gear is falling down at them with the force of gravity. So the little stand that was underneath there got squished down like a soda can in a vice, just slowly squished down, and he jumped out of the way just in time. And the individual that was up in here, had he been laying in a different spot, you can see all this linkage, it would have killed him instantly. I got very lucky that he was in a spot where he rode the landing gear down and then jumped down on the ground, and he was as white as a ghost. like the title up here that says mistakes can happen to anyone. We were the experts in the factory of this process, and we had made a mistake. So we had safety procedures in place, and we're going to talk about safety procedures and hazardous energy and different things like that. But know that when this happened, as a result, we had to change the manual. We had to change safety procedures because I didn't do anything that was incorrect per the procedures. It just wasn't in there. So I had switched, I had flipped a switch to do a different task, unknowing that those two systems were tied together, and it caused the landing gear to go into the emergency procedure where it opens up as if there was a problem in flight. So the two people almost died. And then what happened is that stand was underneath there, and it just crushed this door, messed up these wheels, and scratched that strut to where we had to replace a bunch of stuff and spend hours and hours and hours. But what I'm going to teach you is how to go through when something like that happens, and how to be a professional in the industry. Because as a result of this, I was actually promoted, which is, it's always an interesting thing when that happens, is when you make a mistake, but you get promoted. But really what happened was the fact that I dealt with it in a professional way. I was upfront, and we did an excellent job as a team of fixing this problem. So the management saw just the level at which we did that, and I was offered a promotion because of that. So again, this is an introduction of kind of aviation safety and a real world example of how if you don't follow the safety rules, you get somebody killed. And if there is an issue where you get lucky and somebody doesn't get killed, how you take those types of things and you make them into safety rules to where nobody else can ever have that happen to them again. Okay, so why this is important is pretty straightforward. Safety will always be the first thing that we're considering with anything in our projects in our build a plane class. We're going to be doing several different things on different parts of aircraft that none of you have ever worked on before, and we're going to be using tools that some of you have never used before. So not following the safety rules will get yourself hurt, and it's always karma. I didn't get hurt when I flipped that switch in the wrong thing. I just about killed my friend. So anytime that you don't follow the rules, it always seems that you hurt somebody else, and we want to avoid that, okay? So safety is everyone's responsibility. I might not be doing the unsafe action, but if somebody near me is doing something unsafe, I might get hurt. So it's my responsibility to make sure that those individuals are following along with the safety rules as well. And we're going to, in this class, you're never going to get in trouble. Always speak up, okay? If there's a safety issue, you need to address it right away, or someone's going to get hurt, and we don't want that. Okay, so what you're going to complete, what is going to make you successful in this class and for this assignment is that we're going to follow along. There's going to be some questions that you're going to answer. They're going to go along with this lecture. And then you're going to create 5 safety rules or steps that will keep us safe in the classroom or lab. Okay, we have some in place, but I'm curious of what you're going to come up with, and maybe we can make the environment more safe after you go through this. It's something to pop into your head that could really make things more safe for us. And then everyone is going to take a safety quiz. It is mandatory that you get 100%. Don't panic over that. You have unlimited tries, okay? What I don't want to do is send you out to the lab understanding 80% of the safety rules. Not going to work, right? We want to make sure before we touch the first tool that we are 100% clear what can keep us safe. So if you miss something on the quiz, what we'll do is you and I can get up and we can go over that specific thing that you missed so that you understand it, and we'll take the quiz again. So let me show you real quick. This, and again, this is attached to your, this is attached to the same Google Doc where you found this lecture, or excuse me, the same Google Classroom that you found this, this lecture under. And you're going to go through, there are 10 questions. And again, there's 5 safety rules that you're going to create when this whole video lecture is over. So they're going to go kind of in order, and then there's some review ones here at the end. But we're going to get to points in the lecture where I'm going to tell you you can pause. You're going to go in here and answer these. The other ones will be reflection at the end. All right. So what we're going to cover is exactly right here. We're going to break down safety into different categories. And when we're done with this, you're going to be an expert in each one of these. So we're going to go over hazardous energies. We're going to go over hand tools and safety procedures to use those. We're going to go over PPE, which is personal protective equipment. We're going to go over FOD, which is foreign object debris or foreign object damage, depending on how we're using it. We're going to talk about MSDS and SDS. SDS is what we use now, but if you ever see MSDS, it's the same thing. Those stand for Material Safety Data Sheet or Safety Data Sheets. And those are going to have the chemicals that we're going to work with, how to be safe with those, goggles, gloves, types of things that we're going to need. And then we're going to finish things up with human factors, which is just going to be the things that we can control to make the environment safe, you know, stress and different things like that. Okay, so here comes our first part where you're going to pause and answer. These questions here, don't worry about going back and filling them in. I just want you to fill in the best that you can. You're not going to be graded for correctness, just completion. I want you to give an honest try. But the first thing that we're going to do is I want you to go to the safety assignment. I'll pause this video in a moment, and then I want you to answer the question number 1, which is name as many safety concerns that you may think will take place in the process of building our airplane. Okay, we're not going to do gear swings, so that's one of them that won't be in there, but you can think along those lines of different maybe checks that we're going to do. But go ahead and pause this video, go to that assignment, and then fill in at least 5 safety concerns that you think were going to happen while we're building our aircraft. Okay, that should have given you enough time to pause and fill that in. If you haven't, please pause now and go and do that. We're going to go into our first section, which is hazardous energies. Okay, there are 4 types of hazardous energies that we're going to talk about before we do anything in this class. And those are electrical, mechanical, hydraulic, pneumatic, and chemical. So hazardous energies are anything that can cause burns, electrical shocks, crushing, pinching, physical strikes. If we ignore these, you can lose a limb or even have death occur if you ignore these. You can think of that big aircraft that I was showing you, the 787. There's 5,000 PSI that runs through that landing gear system, and that's enough to crush you. If you were in the wrong spot, it would kill you. So you have to be really careful of those types of things. So as a maintainer, we're going to be in constant environments where we're exposed to different threats. What's really important is to never become overconfident and think that you have everything figured out and you know how to move forward without reviewing the safety procedures. Because some of these energy systems that we're going to be working on will show no signs that they're in a dangerous state. I mean, you can think of an electrical cord. It can be plugged into the wall. It's not like it's vibrating. There's no red light flashing. Okay, some extension cords have a red light at the end, but if it's in the middle, you might not know. So we're always going to check on the systems and assume that they're in the hazardous state before we do anything with them. The first of those hazardous energies is electrical. So when we're working with electrical equipment, it poses certain physical safety hazards. And what we want to do is to avoid those burns and shock is always, again, make sure that we check the system to ensure that it's in a state that's not dangerous to us. So that can involve getting a multimeter out, pulling circuit breakers, making sure things are unplugged. There's 2 main factors that are going to be the biggest issue for us when we're dealing with electrical safety. And that is that you're going to be overconfident. And like we said before, if you're overconfident, you may assume that there's no power on it, and you grab a hold of that live wire and you're going to get shocked or burned. Okay. The second is that you're going to be really nervous or scared. And I've seen people do this before where they're not sure, and they'll put their hand on an electrical wire and then they'll jerk back. And in that jerking back motion, they can cut their hand on something or knock a wire off and get shocked because they jerk their hand back. So what we need to do is make sure that we're not too confident and that we're aware of all the issues that are at hand and that we're not too nervous to work on the system. If we're too nervous, that's an indicator that we don't know what we're doing and we need to step back and reevaluate it anyway. And we're going to address that kind of stuff later on with human factors. The second type of hazardous energy is mechanical. Mechanical systems are those that are moving around. You can have a compressed spring or even a falling part. So in our area, we have a lot of part storage where things may be above our head. That's a type of mechanical hazardous energy. It's not, I mean, it's gravity pulling it down. It's not as much as, say, a hydraulic system or, 3,000 volts or something crazy like that. But, a 20-pound part that's above your head falls down. It's enough to break your foot. It's enough to crack your skull. You have to be really careful with those types of things. The other type of thing is the pinching points. We're going to have a lot of that with just using hand tools. So we just need to be careful with those types of things while we're working on them. The third type is hydraulic pneumatic. This one we're going to be using just about every day in the form of our air tools. So we're going to break those down a little bit more specifically. The airplane that we're working on doesn't have much of a hydraulic system. It's got brakes. We'll talk on those in a little bit when we get to that point of our build. But compressed air or fluid is like electricity. It's an excellent tool for working on things, but there's certain do's and don'ts that we want to follow along with in order to ensure that we're not going to get hurt with it. So the first is we always want to inspect the air hose to make sure that there's no breaks or worn spots in it, because it can cause our drills or other air tools to underperform, and it can cause them to break and then hurt us. So we always want to keep things in a no leak condition. We never want to use compressed air to clean hands or clothing. There's plenty of horror stories where people take the blowgun and they try to clean stuff off their hand. There's enough energy in that compressed air to take a sliver and drive it into your skin. And then you got to go to the doctor and you got to get that pulled out, because it can drive it far enough under where you're not going to be able to get it out like a normal sliver. You have to go in and potentially get it removed. And it's no fun. The shortcut that it would take to use compressed air to clean off your hands or clothing, it's not worth just going over and getting our brushes and brushing that off lightly. That won't get you slivers. Using the compressed air will. And because that can happen, we never want to spray compressed air at someone or other people, because you can drive things into ears, eyes, nose. It's just a bad idea. We don't want to do that. And when we're putting them away, we want to make sure that we coil them up. They can be a real big tripping hazard. And then if we don't put them away properly, they can get cut, and then they can leak on us and we'll have to get them replaced. One thing that you don't want to do is check for leaks with your bare hand. Okay, our shop air does not have enough power to penetrate your skin. But if we had a hydraulic leak and you tried to reach your hand up behind it to see where the leak was coming from, that hydraulic fluid's coming out with enough pressure to go through your skin. And because of that, we always want to use eye protection, that we don't want to get anything blown up into our eyes. And then we're actually going to use hearing protection as well. When we disconnect the hose, it's not that it's so loud. It is a little bit loud. The real issue is the pressure that comes out of there can rupture your eardrum. So if you're going to be disconnecting the air, you're going to want to make sure that you have your hearing protected when you do that. The last one that we're going to look at as far as hazardous energies go is chemical. Now, chemical energies are those, for us, it's really going to be our cleaning solvents, our paints, our adhesives, because those use a chemical process to harden or dry or to remove items. That can have one effect on aluminum that we really like, as in like removing grease. And then if it gets on our skin or in our eyes, it'll have a completely different type of reaction that we don't want. So you have to be careful. I mean, some of these chemicals are flammable. You can have explosions. The burns, what can happen is from it starting on fire, or you can get an actual chemical burn, which is where you leave the chemical on the skin long enough that it starts to eat away at some of the skin and it'll cause a burn-like reaction. Another one that we need to be careful of, and we have respirators for this, are the fumes. There's plenty of stories of people not respecting the chemicals that they're working with, and the fumes can overcome them and cause suffocation and actually lead to death. We also need to worry about skin and eye irritation. That can cause blindness. So we're going to be really careful. Anytime that we're dealing with a liquid, we're going to have goggles on to make sure that that liquid can't get on our forehead and roll down into our eyes. Okay, that gets us into something that we're going to use every single day, and that is using hand tools. So we'll be using hand tools for the entire project. We'll begin to become professionals with this. So this is where complacency comes in. You're going to get really, really good at installing rivets and drilling things, but you still need to be careful, because the biggest issue that we're going to face is going to be using that tool incorrectly or using it for a job that's not intended to do. You can see our little picture down here. You can see, again, he's using the wrong tool to try to get that manhole cover up, and he's bending all of his screwdrivers. And you can see his friend over here is upset with him because it looks like something went flying up and hit him in the eye. Okay, the more comfortable you get with tools, the more that you're going to use them incorrectly. I have to check myself to make sure that I don't just pick up the nearest tool and just use it to get the job done quickly. Okay, we're going to act like professionals, and that means taking the time to use the correct tool for the job in the correct way. Okay, if something's broken, we're not going to use it. It's going to get somebody hurt or it's going to damage the plane. Okay, we can get cuts and punctures in the skin. We can get abrasions, contusions. We can damage the aircraft, and you're going to hurt your ego. Okay, if you use the wrong tool, maybe 9 times out of 10 you get the job done, but it'll only take once for you to hurt somebody, and you're going to feel terrible, or you're going to damage the aircraft, and we can't finish our project. And I'm going to tell you, you're going to feel awful if you're the one that didn't take the extra 10 seconds to walk over and get the correct tool for the correct job, and you damage our aircraft, where we all have to wait because we can't afford to move forward, or we have to go back and fix whatever that issue is. So that's something that we're going to be using a lot is hand tools, and we're going to make sure that we're going to do it correctly. Okay, the next thing that we're going to talk about is PPE. We've hinted at it a little bit. We talked about goggles and things like that. So PPE stands for personal protective equipment, and it is anything that we use to protect ourselves from danger. Some common examples are face shields, safety glasses, hearing protection, and in a world of COVID, you've probably heard this before, that's like face masks when you go out. We'll be using those in class if that's an issue as well when we start back up. So what I want you to do now is, again, pause the video here in a moment, and you're going to go to that assignment, and I want you to list as many examples of PPE as you can. If you can't think of any for the class, start thinking of things for other stuff. Football, they wear a helmet, that's PPE. Can't think of anything for golf. Do you need safety equipment for golf? Probably not. But you can think of examples outside of our class to get you going, but I want you to give me at least 5 types of PPE other than these 3 that are listed here that you think that we're going to use in class. Go ahead and pause the video, go to the assignment, fill that in, and then we'll meet back up and move on. All right. Okay, so you can see here's an example of some of the PPE. We've got hard hats, hearing protection, goggles. That's a full body suit. There's some boots. There's some gloves. You can think of all kinds of stuff. I'm looking forward to hearing what you guys came up with when we meet back up. But you can see over here, that's somebody who didn't use their PPE. There's nothing less cool than wearing an eye patch. Wear your safety glasses. Okay, the next thing that we're going to talk about might not seem like safety up front until we consider the fact that we're working on aircraft that are going to carry people in the sky where they can't pull over. So FOD we'll define here through the FAA definition in just a second, but FOD is foreign object damage or foreign object debris. Now this image that you see is from an old fighter squadron photo that from a place that I used to work at in England. It's Lakenheath. If that wasn't so blurry, you'd be able to read it, LN. And what they did is they had a safety board that would go around and kind of check on things to make sure things were safe and we were doing things properly. And one of the things that they did is they had that bolt here, and this thing is huge. It's like an inch bolt. Like that font is big enough to read from like having your hand stretched out. It's not real small. And they call it the golden bolt because what they did is they would hide it in places that they knew an aircraft wasn't going to go, but people would. So they knew that if you were paying attention and keeping your eyes down on the ground and looking out for FOD, that you would find it. Now, the cool thing is if you found that bolt, you would bring it to them and show them, hey, I found this. You tell them where you found it, when you found it, and they would set things up to where you would get to go for a ride in an F-15. Now, as much as I would love to send everybody in our class on a ride in an F-15, we don't quite have the budget for that, and I don't have those connections anymore. But we may do something like this to where I hide a piece of FOD in our area where you should be able to see it. And if somebody sees it, maybe we do some extra credit, or we can do some kind of prize for somebody who finds that. Okay. Now let's break down formally what FOD is, and then we'll talk about why it's important to think about this from a safety standpoint. Okay, so FOD is defined by the FAA is any object, live or not. Think about that, because you can have bird strikes or something out on the runway that's not supposed to be there, like a deer or a moose or something like that crazy. But FOD is any object, live or not, located in an inappropriate location in the airport environment that has the capacity to injure airport or air carrier personnel or damage aircraft. So that's where the safety component comes in. If we're working on an engine and we leave FOD, things that aren't supposed to be there, to where the engine can suck that in, that could cause that engine to damage and start shelling out pieces and damage the aircraft and hurt personnel on the ground. We don't want that. okay? Something laying where it's not supposed to be can really, really mess things up and cause a real big safety problem, especially at 30,000 feet. If you have a bolt where it's not supposed to be, it can roll down and jam up flight control surfaces. It can short out electrical circuits, cause all kinds of problems. So while we're in class, we're gonna really focus on the idea of keeping our space clean and keeping areas clear of fog. Okay, so fog creates safety hazards and can ultimately impact the safety of operations and damaging aircraft. So it's a huge concern by the FAA, and it's something that has caused several different incidents throughout the history of aviation. So for us, FOD, we're going to keep hangars, shops, and the flight line in orderly and clean and essential for efficient maintenance. You can't fix an airplane well if there's crap laying everywhere. You just can't do it. And there's multiple reasons for that. One, it's not professional. If you were going to drop your airplane off to have somebody fix and you're spending thousands of dollars and there's just junk laying everywhere, do you really feel comfortable with that person? Probably not. And if you were about to get on a 747 and fly across the Atlantic Ocean and you saw just crap laying everywhere out on the runway, you're not going to feel too confident that the people that are flying you there know what they're doing. So one is professional, and two, it really does reduce safety issues. So we're going to reduce this by properly storing our tools, our work stands, our hoses, electrical cords, any hoist that we're using, crates, boxes, any parts that we have. We're going to make sure things go back to where they're supposed to be, because we want to make sure that we keep signs posted to indicate dangerous equipment. And if the sign is posted, but the equipment's not there, then what good is that doing? We want to keep the equipment where it's supposed to be with the sign right there so people know if it's in a safe state or not. Also with FOD, if stuff's laying everywhere, we can't keep safety lanes. If we have a fire, we need to get out of the high bay. And if we have stuff laying everywhere, if there's FOD all over the place, there's gonna be people tripping, and we don't need that. We want a nice safe lane for us to get from an area to another area in an emergency if we need to. Okay, and as I said before, safety is everyone's business. Communication is key to ensuring everyone is safe, and that includes FOD and any other issues that could come up along the way as we're working. If someone's working messy, it's your responsibility to tell them, hey, slow down, let's clean up the area, let's put the tools back before we get going. Okay, that leads into the second part we're going to talk about, which is tool control. Okay, this is a picture of what our toolboxes used to look like. We've got it even better now. We've got a foam cutout. I am outside of the building because of COVID right now. I will update that slide when we get a chance. But even this here, you can see before we had the foam cutout, it's neat and organized. If we were to pull out that bright orange ruler, you would know it's gone. And when something's missing, we know we got to start looking through the aircraft to find that. We can't just let the airplane go and fly if we're missing a big tape measure or a screwdriver or one of these utility knives. Okay, so if you organize your tools, we know where everything's at. We don't turn one of our tools into something to fix the aircraft. And by keeping track of it, we don't have it turn into something that causes the aircraft to crash. And there is, again, countless examples of technicians that have left tools out that have caused aircraft to crash or malfunction. So what we're going to do is we're going to check our toolbox every day before we start class and when we're done with a job, and definitely at the end of class. Now, the reason we check in the beginning of class is if this bright orange tape measure is missing before we started, we go look for it, we get a hold of the people that are working before us, we know that we didn't lose it, okay? Because if we rebuild an engine and we spend 12 hours, we rebuild the engine, we put it all back together, we go to check the tools and that tape measure is missing, guess what? We're taking that engine back apart unless we can prove or find that tape measure. Okay? Even if it was gone beforehand, we don't know, we didn't check. And because we can't be 100% certain that it's not inside that engine, we can't start it, we can't send it out to go fly. We have to take it back apart. And I'm telling you right now, there is nothing more heartbreaking than spending 12 hours working on something just to take it back apart because you can't find a tool. Okay, this is something that we can do before class so it doesn't have to take up time. We get in early, check the toolbox, it's done. We can move on. Okay, the way it's going to work is there's always going to be accountability. So if we use tools that day, we're going to check before and after. And then what you're going to do is at the end of the day, you're going to call me over and I'm going to check the toolbox. If something's missing, we're not going anywhere. Okay, we're going to make sure we find it. And if we give an honest effort, we still can't find it, we're going to tag everything that we worked on that day is that we can't move forward with it. We have to find it before we can close any panels up, before we can install any of those components that we're working on. So it's non-negotiable. We lose a tool, we're stopped. We can't move forward. So it's one of the most important things that we're going to do. But this isn't a big deal. It's going to take you probably 5 minutes to check the box the first week, and then it's going to get down to where you're going to be able to check in your sleep. When I look at this picture, if you pull one tool out, I'll know right away. Same thing with our boxes. It takes me about a minute to check both boxes, and I check them very thoroughly. But I'm just so used to what's in there. I know right away when something's missing, and you're going to get the same way. Okay. So the effects of tool control are what we talked about earlier, which is FOD laying around and causing missed tools to damage things. The other really cool thing that I want you to take away from this class is just how efficient it is to work clean. Okay. If our space is clean, then we work safer. You don't stop to go put Band-Aids on. You don't stop because you hurt somebody else or any other reasons that you would have to stop work for FOD or anything like that. And that causes you to work faster. Okay, the cleaner you work, the faster and more efficient you will become. It's gonna become second nature because I won't let you work in a pigsty. If things start getting dirty, I'm gonna walk over, I'm gonna stop you, and I'm gonna help you. We're gonna get back together. We're gonna clean things up, and we'll get going again. When I was in the Air Force, I learned this the hard way. I had a staff sergeant that would go around, and he would see, we'd get all excited to be working on something that's really fun to do, and there'd be just a pile of tools on the floor. We'd be up working on something. As soon as I'm done with that wrench, set it down, grab the next one, do the next thing. And he was really good. He knew exactly what we were working on. He knew exactly which tool we were gonna need. And he would creep up when we've got just a bunch of tools laying everywhere. And he would creep up and he would steal the exact tool that he knew we needed, and he'd put it in his pocket. And he'd come by and he'd wait, he'd keep an eye out. And as soon as he saw us kind of panicking and looking around, and he'd come up and be like, "Hey, what's going on?" And we'd be like, "Well, we can't find the 3/4 inch wrench. We don't know where it went." He goes, why can't you find it?" And we'd be like, "Well, we weren't putting our tools away." And he'd pull it out of his pocket, and he wouldn't give it to us right away. He'd make us clean everything up, and he'd read us the riot act before he'd give it back. And it didn't take very long of that staff sergeant doing that before you either kept an eye out when you were working quick, or you did the right thing, which is what we ultimately did in the end, which is you work clean. And he didn't have tools to steal because they were back in the box. He'd walk up, and rather than steal a tool, he'd help you out. And he didn't do that to be mean. He was trying to prove a point. He was making us better. I mean, it became second nature, and we were way more efficient. So don't be surprised that if you're working in a messy environment, that all of a sudden you're missing a tool. Mr. Jansen may have put it in his pocket to prove a point to you. Here's a good example of what working clean looks like. This is from your fellow students. This is from students just like you. So don't tell me that it's not doable. It completely is. Okay. They work nice and clean, and they were able to get it done. The only time that students don't do this is when they get really excited because it's fun to take a jet engine apart. And I completely understand that. And I'm not going to be mean. I'm just going to come over and say, "Hey, let's straighten things back up." And I'm always going to kind of show you this picture of how things can be laid out. You can see this is almost laid out like a Lego illustration, right? You can see how the pieces would fit back in here. Take this piece, put it there, and kind of put them back in one by one. And if you lay things out that way, you may think you know exactly how they go back together, but if some hours go by or a day goes by because we have to go to our other classes, you might forget how things go in. But if you lay them out in an order just like this, they're going to go back together just fine. You're going to remember like, "Oh yeah, okay, we put the case back on. All right, and then we're going to put the cover back on. Then we're going to put the bleed air back on, and the duct back in, and the bracket back on, and the bolts to put it back on, and then the clamps to put it back in." You're going to have it laid out in order to where you're going to be able to put it back together. Even if you forgot a little bit, it'll be it'll help you follow along with the manual to put it back in. All right. The next thing that we're going to talk about is the MSDS or SDS. Again, SDS is what you're going to see more frequently, and that stands for Safety Data Sheet. This is just a document that contains information for the potential health effects or exposure to chemicals or other potentially dangerous substances. We're going to have MSDSs for acetone, rubbing alcohol, our paint, our adhesives, things like that. Okay. I'm going to pull up an example of an MSDS, or excuse me, an SDS here in a second. There's more information on there than what you need. Okay. There's stuff in there for how to ship it. We're not going to ship any of this stuff. There's information in there for the fire department to know how to put it out. Okay. You keep an SDS, a list, a library of the chemicals that you have. And you keep that on hand in case your place of business or where you're working starts on fire. The fire department can reference that and not run into a building that's about to explode because they know there's a bunch of propane tanks in there. Okay. So there's safety for that in there. And then there's the stuff in there for chemists and for engineers. We're going to go through and I'm going to show you what I want you to be responsible for is how to scroll down through the SDS and find what protective equipment you need to make sure that you're safe. Okay, so here's an example. This is kind of the first page. And I'm going to hit this link here. It's going to pull this up. And we're just going to take a look at acetone. You may know acetone better as nail polish remover. So if you've ever put nail polish on before or removed nail polish, you've put this on your skin. Some of the stuff that we're going to use is a little bit stronger. So this is where being complacent and saying, oh, I've used nail polish remover before. I'm not worried about wearing my protective equipment. Well, this stuff might not be exactly the same, so we need to be careful with it. So we're always going to take the SDS and we're going to read through. And you can see there's sections up here. This is just the, the product and company identification, hazardous identification, composition, first aid measures. This is what we're going to do if it gets on our skin, if it gets on our eyes, if it gets, if you inhale the vapors or if you ingest it. Okay. Again, here's the firefighting measures. Here's what happens if we accidentally spill it. How do we take care of spills? And right here is handling and storage. This is what we're going to look at. Excuse me, no, we're going to look at 8. So here's handling and storage. We've got a flammable cabinets locker. That's where we're going to keep all of our chemicals at. But right here, we're going to look in. This is where it's going to tell us our PPE. Okay, so here's eye protection that we're going to use. If we're using this acetone, we're going to need splash goggles. Gloves, we're going to need to wear gloves to make sure that we keep it off our skin. Other protective clothing. This is if we're going to be using big quantities of it. So we might not need to put on some big suit if we're just going to put a little bit on a rag and clean off an area before we put some adhesive down, something like that. That's where we'll use gloves and goggles. Here's what we talked about with chemicals again. If you're going to be using this in a confined space, that is where the vapors can overtake the oxygen that's in there and cause you to pass out. So, well, it's not that it overtakes the oxygen, but it's in a confined space where you're breathing it in and it's going to get into your lungs and you don't have that fresh air that you can breathe in. So this is where it's recommended if you're going to use this acetone in a confined space that we're going to want to make sure that we have some kind of ventilation in place. Okay, and it's going to tell you don't eat or drink in areas, don't smoke, and discard any clothing or protective equipment that becomes, that cannot be decontaminated. So if we get a rag that's just absolutely soaked with it, we're going to get rid of that. So what we're going to do is we're going to get used to reading through these. We're always going to flip down here to section 8. We're going to read through the whole thing, and I'm going to, before you use the chemical, I'm going to ask you, what protective equipment do you need to use? How do you know what protective equipment you need to use? And that's not going to be something you have to memorize. I do not want you to go through it and memorize them. If there's some things that you know, quick reference, that's fine. But before we touch any chemical, we're always just going to reference to this in case there's been some kind of update, because we always have the most up-to-date SDS. If there's been an update where they said, hey, it turns out this is really bad, and you need additional protective equipment. Examples of that are asbestos. So asbestos used to be, you can just use it. There's nothing wrong with it. And then we found out mesothelioma is a thing, and asbestos fibers get into your lungs is really, really bad news. So if you had an SDS of that chemical asbestos from 50 years ago, it might not say that. You want an up-to-date one, which is why you always reference it. You never know when there's going to be a new update. All right. That gets us into one of the last sections that we're going to talk about, which is human factors. And we're going to spend a little bit of time on this. We went through the other ones a little bit quick because those are going to be things that as we do them, we're going to make sure that those safety processes are in place. Those are things that we can slow down and make sure that we're doing correct as we go along. And not that those aren't important, but human factors, and we're going to break down what that is here in a moment. We've got what the FAA calls it the dirty dozen. But the human factors are such a big role in aviation incidents that they make up 75 to 80% of those. It's really the number one thing that's going to be able to keep you from making an accident or having a safety issue. So we're really going to focus on these. These are the things that I'm going to trust you to make young adult decisions. That if you're in a state of mind where you're not safe to work, tell me that. That is fine. There is no pressure. This isn't a test that has to be done. There's no time limit on this. If we have to step back because there's something else going on that's keeping you from operating with a clear mind going forward, then we're gonna do that. We're gonna step back. Okay. We can talk about it later, but some of the issues that happened with that landing gear swing where I cost $1 million worth of damage, there was human factors involved in it. There were some pressures and stresses and things like that. So when you let that creep into your work environment, that's when mistakes happen. So the FAA identifies something they call the dirty dozen. Okay. The dirty dozen are poor communication. That can be between myself and you as a student. That can be between student and student. And that could be between us and maybe a vendor that we're working with. And those can be things to where you just don't fully know what's going on. Say a step wasn't communicated to you very well, and you don't quite know what's about to happen, and you walk into an area that's dangerous. Maybe a confined space with a chemical in it, and you lack that communication, and you walk into that environment, and you've just put yourself into a potentially lethal situation. Or if I'm swinging landing gear, or we're running the engine and we communicate that poorly and somebody walks into that area, they could get hit with a prop with it running, which is a lethal situation, or they could get squished with the landing gear, which again is a lethal situation. So we always want to make sure we're very careful about the communication. If there's any ambiguity or any unknowns, we're gonna stop and we're gonna address those. Don't feel like if I give you a task to do and I explain it to you, that if you have any doubts of what's going on, that you can stop that and we can go back over it again. So don't let poor communication be a hindrance from safety. The second one is complacency. That we've been talking about that a little bit, especially with our hazardous energies. And that is every day that I walk in, the airplane is never turned on. Why would I check it? It's never turned on. And the one time I walk up, somebody left it turned on and I grab a hold of a wire and it's got voltage on it and it shocks me or it burns me. I think that's probably an easy one to think of. We all get complacent. It's going to happen to us. Okay. We need to be the adults in the room where we step back, and when we see ourselves doing that we take a step back and we address that problem. The third one I think kind of leads into the poor communication as well. They're kind of related to each other, and that is lack of knowledge. You guys are students. You have not built an airplane before. You are, by definition, lack the knowledge, okay? That's not an excuse to put yourself in a situation to get hurt, okay? We can point fingers all we want at the end. At the end of the day, if you lose an eye because you lack the knowledge of what was going on, of course, there'll be repercussions for the individuals if it's like myself that told you to go do that task, but you will be living without an eye for the rest of your life. Don't let lack of knowledge be a safety concern. If you don't know what you're doing, do not move forward. Take a step back. This airplane does not have to be finished in a week, a month, or a year. We can take our time. Okay. The next one is distractions. That's pretty obvious. That's going to happen to us. You guys are in high school. You're going to be making college choices. You can have boyfriend, girlfriend problems. You can have problems at home. You're going to be learning to drive. You'll be stressed out over a test. There's going to be lots of things that are outside of the classroom that are going to distract you. When that's happening, take a step back, refocus. If it's too much of a distraction for the day, we can find other things to be successful on. We don't have to weld when you're thinking about your geometry test. We don't have to drill holes into a critical spar when you're worried about something that's going on at home. Communicate that with me. Don't let those things creep into the classroom and cause issues for us. Stress is the next one. That, again, that's just like distractions. The only difference I think we're focusing with stress is specific stress of the task that we're doing. That might be that you're nervous about doing something, or you feel pressure from me or from another classroom or from another classmate. Again, don't let stress, it's equally bad. If your mind's not on what it's supposed to be, you're going to make the mistake, and then you're going to feel bad or get hurt or hurt somebody else. Lack of resources, that's not going to be an issue here. If we don't have the equipment because we lack the resources, we will not do that task. Okay. You're never going to be in a spot where you're going to say, well, Mr. Jansen really wants me to do this. We ran out of gloves. I'll just do it quick. It probably won't burn my hands. I'll just go real quick. No. If we don't have the resources, we're not moving forward. Okay. It's as simple as that. You guys aren't going to get hurt because we ran out of gloves or we broke the drill bit. So we'll try to use the broken drill bit. I'm sure it's fine. No, I'm not going to do it. I'll make sure we get the things that we need. The other one is pressure. That's going to be self-induced. It happens. I'm going to put pressure on myself. You guys are going to put pressure on yourself. What I don't want is you to feel pressure from anybody else in the room or from myself, from me. Know that, like I said with the timeline, we have lots of time to do this correct. Don't feel pressure to get things done quickly. And if you feel pressure from people watching you, just step back. You know, if there's a cool thing going on, there might be people who want to watch it happen. If you're feeling pressure from it and you don't feel like you can perform the task safely, then ask them like, hey, let me do a couple of these and then I'll call you over when I'm feeling more comfortable. Perfectly fine. The other one is lack of teamwork. I really hope this isn't an issue for us. If you feel like you're not being supported from your teammates, let me know and we will fix that because that's not acceptable. But if, you know, we're in a high school environment, it happens. I get it. Just don't let a lack of teamwork cause you to do something that's unsafe. If it's a two-person job, do it with two people. If they don't want to help that day, there's plenty of people in this room that want to help you out. If it's a two-person job and your partner's not pulling their weight, let me know. I'll find somebody who will help you out. Lack of awareness, that's kind of what we talked about before. You don't want to walk into an area where there's hazardous energy. You don't want to knock something off a shelf. Be aware of what's going on so that you don't get yourself or somebody else around you hurt. Accepting the norms. This one's a little bit confusing for students, but I think once I explain it, you'll kind of get that. That is, I think the best way to explain it is to give an example. Oh, don't worry about wearing goggles, Mr. Jansen. We don't do that around here. That nobody uses safety glasses for using the grinding wheel. That's just how we do it around here. That's accepting the norms. Where you walk into a place where you work and like, oh, we never do that step. Don't worry about it. That's accepting the norm. You've just, you've put yourself in a situation where you're knowingly violating safety protocol because nobody, that's just how they do it there. That's real common. I've been many places working, and you will too, where they just don't do certain things. Don't let that culture exist. It's going to be difficult to stand up for it outside of this class, but it's the right thing to do. In our class, I can tell you that the norms will not be to violate safety rules. If you ever feel as though they are, you bring them to my attention, we will fix that, okay? We're not going to foster a culture of violating any safety protocol at all. Fatigue, this one's, it's going to come with the territory of being a high school student. Biologically speaking, you guys need more sleep, and it's better that you sleep in later, but that's not how school works. You might be a little bit tired when you come in. If you're dragging it and you're not feeling it, wake yourself up, walk around a little bit, maybe listen to some music, get going, but do not walk into our work area falling asleep. If you can't stay awake, we'll find something for you to do to be productive that doesn't involve safety issues. Because the last thing I want you to do is be drilling a hole and fall asleep and fall down. And that's bad news, right? The last one here is a lack of assertiveness. That I think goes along with accepting the norms, lack of knowledge. They all kind of really tie in with each other. And that is not raising your hand. If you see an issue, if you see Mr. Jansen out there drilling with his glasses, his safety glasses off, and not being assertive and say, hey, Mr. Jansen, you gotta go put your safety glasses on, it's gonna lead to an issue. You can be assertive. You're never gonna be, if I'm doing something wrong, I'm not gonna penalize you. I welcome you to do it. I probably forgot, I've gotten complacent, or I've let pressure get to me, or I've let stress get to me, or I've lost a sense of awareness of where I'm at. I need you to be assertive and say, Mr. Jansen, you need to stop and get your safety equipment, or you're doing that unsafe. I'm going to do the same for you. It's going to be a partnered system. We just need to watch out for each other. So those are the dirty dozen. They kind of show up. I feel like they're common sense type things, but we really need to point them out. And we're going to visit these from time to time. We're going to have one of the day that we're going to focus on and really try to get used to dealing with these. Okay. This is where we're going to stop again. And you've got two more questions, question number 3 and question number 4 that I want you to answer. I want you to look at this picture here, and just so you know, there's no one correct answer, but I want you to tell me which one of those dirty dozen does this picture right here represent? A boss yelling at an employee. And then also, which of the dirty dozen do you think are going to be the biggest issue in the classroom? And you can say for the classroom as a whole or for you individually. Either way, there's no wrong answer for these two questions. All right, pause the video, answer those, and we'll be back up in a moment. All right, the next thing that we're going to talk about is something that we use in the flight program, which is the I'm safe. And that is, you're going to run through a checklist. We're going to do this every day. Do you have any illness? Big deal right now with COVID, right? Stay home. If you don't feel well, stay home. Your mind's not going to be in it. You get other people sick. M, do you have new medications? Maybe it's going to affect you a little bit. You be careful with that. Stress, alcohol and drugs. If you've taken any alcohol or drugs, do not work in our shop. There's a whole, we can attack the whole issue later about being underage and using these things. If you find yourself in this state of mind, don't work, and we'll address that. We'll address that problem. Just so you know, the industry standard is alcohol is 8 hours. When I had that issue with the $1 million worth of damage, instantly I had to go take a drug test and a breathalyzer. Should I have failed either one of those, I would have potentially gone to jail. Fatigue and eating go together, I think, a lot. If you skipped lunch, you're tired, you need to eat, I get it. We're going to step out of our lab. If you need to take care of that, that's fine. What I don't want you is hand shaking because you haven't eaten today or you're tired. Okay, so this is a little self checklist that we're going to run through every day and make sure that we're good to go on these things. Okay, this is the power that I'm giving to you. Okay, all safety concerns are going to be recorded and addressed. I'll take care of that. The power I'm going to give to you is the knock it off. Okay, once the safety issue is stopped, once the safety issue is spotted, we're stopping. Okay, your job is to say, knock it off. I don't care who's doing it. I don't care if the principal comes in and is working on stuff. Tell them to stop. Our area requires safety glasses. If somebody's in there without them and they get hurt, that's on us. We don't want that on our conscience. Okay, you have the ability. I don't care if the president comes in. You knock it off. Safety is first. It's the most important thing that we're going to do. So you have that power. What we're going to do is, if it's new, or if it's egregious enough, or if it's a big enough deal, we're going to do a stand down, which is where we're going to stop what we're doing. We're going to address it so nobody else makes that issue and gets hurt in any way. Okay, so here's how we get safety rules. There's no magic to safety rules. There's 2 ways you get them. One, you didn't think the procedure through and someone got hurt, or you damaged $1 million worth of aircraft. Or 2, you stopped ahead of time and you thought things out as thoroughly as you could before something got damaged or somebody got hurt. We're going to do everything in our power to do the second one here. Let's be that second thing there. Okay. Here's examples of some safety rules. You're going to write some. I'd really love for you to get specific. If you know some tools that you've worked with before and you know some really good specific safety rules, or tips. I want you to use those. But if you need to start general, these are the ones that are posted in our high bay. Always wear your safety glasses, do not distract other people. There are common sense type things. We're going to address these when we meet back up with your own safety rules. So I'm just going to leave this slide up here for you to reference back to, should you get a little bit stuck. Okay, but these are kind of some of the basic ones. We're going to have specific right here. You see the observe any equipment, material, operation, or tool specific safety procedure. So this is our general thing, but if we're dealing with a bandsaw, we're going to follow along with the specific rules for the bandsaw. Okay. Okay, so what you're going to do is you're going to make some of your own rules. What I'm going to do is, again, here's some examples, but I'm going to walk you through of how you can think about these rules and how you can generate one. So let's think about the landing gear falling down and hitting somebody. Okay, a safety rule could be before going underneath the aircraft, you must ensure that all personnel are informed that you are under there and that the circuit breakers have been pulled so that nobody can accidentally activate the system. That is an actual rule that we wrote into the steps because of what happened with the choice that I made and that the two teammates that just about died and the $1 million worth of damage that we had. It's an issue that happened, and then we went through and wrote a rule very specific of how that thing cannot happen again. Now, that wouldn't be a rule that you would post on the wall. That's not like our high bay rule. We don't need to post that. We don't need to know that every single time. What you do is you write that into a step. That would be down here where we have observe equipment, material, operation, and tool specific safety procedures. So if we're doing something very specific, that's when we put that safety rule in big and bold where people see that. You know, step 1, ensure that power's not on. Step 2, you know, and keep going down. That's where you put those safety rules in place for that. Okay, so that's going to get us, again, let's go back to here. These are the things that you're going to do for me. Is you can rewatch this lecture. I talk kind of quick, so you probably don't need to speed it up that much. You can slow it down if you'd like. But feel free. I know all of my lectures, once I go through it once, and if I need to listen to it again, I'll increase the speed. So feel free to do that and go through and answer some of these questions if you don't remember them. And what I'm going to be looking for is for you to list 5 safety rules that you think will make this class a safer place. Again, start broad if you have to, but the more specific that you can get, the better that we're going to be. Okay, so if you know a little bit about drilling and you want to do a specific rule on that, that's fine. If this is your first hands-on class, use those high bay safety rules as a good springboard. Okay, I'm going to be grading these as far as effort goes. Okay, I'm not gonna if I can look through here and see that you gave an honest effort of trying to come up with a safety rule that keeps us safe, you'll receive full credit. Okay, if you put down things that are just a rehash of our high bay rules like this and you just reworded them, and I can tell you didn't really try your hardest, that's when you're going to lose points. Okay, but you really I just want you to go through and list 5 safety rules. We're going to share them out as a class. If you're the kind of person who doesn't like sharing them out, I get it. This is really important. We'll work on sharing out in front of the class later. You'll get more comfortable speaking. This is one of our first assignments. So if you're really uncomfortable speaking, if you want to just email me these ahead of time, and I can share them out. What's really important is we get them out and that people know our safety rules. And then once we do this, I will activate the quiz and we'll all take the safety quiz. Again, it's going to be based off this lecture. There's not going to be any surprises on it. Nobody's new safety rules are going to be on there. It's already written. So if you understand this lecture and you're comfortable with the topics that we went over, you're going to do fine. If you don't do fine, if let's say you get a 0%, we'll just go back over it. It's fine. I want to get you to a point where you're comfortable so that when we enter the class space and we're starting to work on things, that there's no issue with safety. All right, those are the things that we do. Email me if you have any questions. Again, you can watch the lecture if you need to, but that should do it for us.